You're welcome to my channel, Mindset Academy, where we want to solve the problem that is displayed on the screen. And the question is involving tolerance and fit. The question goes like this. It says, the tolerance for a hole and a shaft assembly having a nominal size of 50 millimeter are as follows. Hole equals to 50 to the power 0.025, 0.000, and shaft equals to 50 to the power 0.045 minus 0.080. Determine the following. Roman figure 1, maximum and minimum clearance. Roman figure 2, tolerance on shaft and hole. Roman figure 3, allowance. Roman figure 4, the maximum metal limit of hole and shaft, that is MAL. Roman figure 5, type of fit. Now, before we proceed in solving this problem, we need to understand one or two things here. When you hear the word a shaft is meant to fit into a hole. Sometimes the shaft will easily go through the hole. When I say a hole, I mean a hollow ring, right? So the shaft is made just like your ring, the wedding ring fitting into the finger, right? So the finger here, we see it as a shaft, and the ring that is fitting into the shaft is said to be what? The hole. So the shaft is meant to fit into the hole. Most times you have difficulties in fitting in, right? And most times you just pass in through easily. So that's why we have different kind of fit. We have the clearance fit, the interference fit, and the transitional fit, right? So we proceed. Now, the first thing you need to do is to draw your table, right? And you separate the two components, which is the hole and what? And the shaft. Now, the 50 you see here is the nominal diameter of the shaft and the hole, right? Now, what you need to understand is we need to get the upper limits of the hole and the shaft, including the lower limit also of the hole and the shaft. So let's start. So for the upper limit, it will be the nominal diameter of the hole plus the upper limit here, right? And that will give us 50 plus 0.0025. That will now give us 50.025. Is that taken? Millimeter. And the lower limit of the hole will give us 50 plus whatever is down here, 0.00, and we'll have 50.000. So we are done for the hole. We've gotten the upper limit and the lower limit of the hole. Now for the shaft, the upper limit of the shaft will be the nominal diameter 50 plus what is up here, which is the upper limit here, will be 0.045, right? Equals to, that will give us 50.045. And the lower limit will give us 50 minus what is up here, 0.080. I'll be having it to be 49.92 millimeter. So we've gotten the upper limit of the shaft and the lower limit also. So we proceed. The first question here is making us understand that we need to calculate for the clearance. Now to calculate for the clearance for the maximum clearance, right, which I can also call the maximum allowance, it is the upper limit of the hole minus lower limit of the shaft, right? And the upper limit of the hole here is given to be 50.025 minus the lower limit of the shaft is given as 40, That will be 49.92, right? So we're having it to be the maximum clearance will now be 0.105. Similarly, the minimum clearance I would also call the minimum allowance. That will give us the lower limit of the hole minus the upper limit of the shaft. So this will give me 50.000, or I will say 50, minus we have 50.045. So we'll be having this to be minus 0.045 millimeter. So we calculated for the clearance, maximum and minimum clearance. Now, the next thing here on the table is we should calculate for the tolerance on the shaft. Now, the tolerance on the hole will now give us the upper limit of hole minus lower limit of hole, which will give me 50. For upper limit, we have 50.025 minus, for lower limit, we have 50.000, or we say 50, and that will give us 0.025 millimeter. Is that okay? Now, for tolerance for the shaft, on the shaft will give us the upper limit of the shaft minus the lower limit of the shaft. So upper limit is 50 of the shaft is giving us 50.045 minus the lower limit of shaft is 49.92. So this will now give me 0.125 millimeter. Is that okay? Now the next thing here we're told to calculate for is the allowance, right? So the allowance here can be calculated by saying that is the maximum metal condition of the hole minus the minimum metal condition of the shaft. So the maximum metal condition of the hole is the lower limit of the hole minus the minimum metal condition of the shaft means the upper limit of the shaft. So that will give me 50.000 minus 50.045. So we're having this to be 0.045 millimeter, right? That is for the allowance. Now, the next thing we are trying to do here is to calculate for the mml of hole and shaft. That is the maximum metal limit of both the hole and the shaft. So to calculate for the maximum metal limit of the hole, which is also called the lower limit of the hole, that's given as what? The 50. That is the diameter there. We are taking the nominal diameter. While the maximum metal limit of the shaft is equals to, is the same thing as saying the upper limit of shaft, which is equals to the lower limit of hole minus the allowance, right? So what do we have here? We have this to be 50.000 minus the allowance, which is minus 0.045. The minus will multiply the minus become plus, so 50.000 plus 0.045 will give us 50.045 millimeter, and that will give us what? The mml for shaft, so which is also the upper limit of shaft. So we move forward. Now the next thing is we should calculate the type of fit. This is given. One thing you need to understand is if the upper limit of the shaft is less than the lower limit of the hole, there will be a clearance, there will be an interference. That means the shaft is bigger and the hole is smaller. So the upper limit of the shaft, that is the outer diameter of the shaft, is less than the inner diameter of the hole. There will be a clearance because the shaft is smaller than the hole, so it will be able to go through. But when the other way around, the shaft is bigger than the hole, there will be a kind of interference, right? So in this case, if you look at the upper limit of the shaft, right, it is bigger than the lower limit of the hole. So there won't be any clearance, right? So if you have found this video helpful, please don't forget to like, subscribe, and also share the video. Thanks for watching.